Yeah, hi. Let's continue machine learning using R. And today I want to talk about how to perform naive Bayes. And I'm going to introduce two R packages. One is E1071, and the other is called naive Bayes. Okay. First, brief overview of naive Bayes. Naive Bayes is a simple probabilistic classifier based on Bayes theorem with a naive independence assumption among features. And it's fast to train and predict, often performing well on high-dimensional data like text. And variants include Gaussian naive Bayes for continuous features, multinomial naive Bayes for counts and discrete features, and Bernoulli naive Bayes binary features. Okay, so when you use these R packages, you need to be very careful about the type of data for the predictors. Okay, it will sync any continuous variable as a Gaussian random variables, and then binary variables as Bernoulli. Okay. All right. So the core idea is to compute the posterior probability for each class and choose the class with the highest posterior. Okay. And based on the Bayes theorem, of course. And its strengths, it requires less training data, robust for text classification, and scales well with features. So it is really a very naive, just a simple idea, but it is pretty quick and dirty, and doesn't need much training data, and in some application actually does a pretty good job, like text classification. Okay. Its limitations include mostly on the independence assumption. It rarely holds exactly, so performance can suffer with strong features correlation. Okay, and we need to do smoothing, which is controlled by the Laplace option in the packages. Smoothing is often needed to handle unseen features. So here you can see I did not load the two libraries because there's some similarity about the function names and the package names. So I'm going to use the double colon method to call the functions. So first, let's just generate the data set, we generate the class, get them name ABC, and then for each class, generate data, and then this is the generated data for the ABC, and then we create a categorical predictor and two continuous predictor. Okay. And we really don't need this set data frame command here. So let's create the training data set and the test data set. Okay, so you can see for fitting the naive Bayes model using E1071, you can see the syntax or the function is naive Bayes with a capital letter B here. So, and it has the interface class regress on V1 plus V2 plus cat. Because when we were creating the data set, we already made V1, V2 numeric and cat as a factor. So we don't have to do additional data pre-processing. We just can use this formula and then data go to training data frame. And then, so it's very quick to fit the model. And then we can do prediction. We can generate the table. Classification table and calculate the accuracy. Okay, and then we can use the naive Bayes package. The function in that package for naive Bayes is naive underscore Bayes. Okay, and the syntax is similar. Okay, so we do that, and it has actually give us a warning message, just saying the feature cat has 0 probabilities are present. Ask us to actually consider Laplace smoothing. Okay, so and back up to the E1071 naive Bayes, it did not even give us the warning. Okay, so there's a subtle difference between the two packages. We can do the prediction, calculate the classification table, and the accuracy. Okay, so you can see the accuracy is like 92.8%, and then we can display the classification table and the accuracy, which are identical to the outputs from the e1071 package. Okay, so these two packages are they both handle mixed types of predictors. Should very often should give identical or very similar results, except there's some subtle difference of how they return posterior probabilities, how they handle the smoothing, and treatment of categorical variables, etc. So they're mostly similar, but there's some subtle differences. Just keep that in mind. Okay. Okay, so I want to also do some demonstration about how do you specify priors and smoothing. So basically what this is you can, if sometimes you have like a severely imbalanced data set, so you have many more data points in one class compared to other classes, and you want to redistribute the priors, you can use these priors option. So for example, we can specify I want to put 40% on A, 35% on B, and 25% on C to get started. Okay. So to implement that, you want use this command. So let's specify the prior, and then you can see everything the same, but you put priors equal to priors and Laplace equal to 1. So the Laplace equal to 1 is say you want to do smoothing. Laplace, by default, Laplace equal to 0, meaning there's no smoothing. Okay. So we want to do smoothing using the Laplace equal to 1 option here. And then you can generate the prediction, and you can generate the posterior probability. If you want to take a look, they look like that. And also you got a posterior probability matrix there. Okay. Similarly, if you want to use the naivebayes package, it's very similar. You specify the prior, and then you use almost the same syntax, but different functions. Okay. Laplace equal to 1, and then you generate the predicted values, the predictions, like that, and also the posterior probabilities. Okay. So if we want to compare the predictions from the two algorithms, let's take a sum of predictions equal to probability underscore MB. And this is like tell us 176, yes. So they have the exact same classification on 176 cases, but they're total 180 cases. So it's not 100%. Okay, there's some differences from the two classifiers. And if you look at the first 6 rows of posterior probability from the e1071 naivebayes, and also from the second one from the naivebayes package, you can see the first few rows, there's some differences. Okay, not all the posterior probabilities are the same. Okay, but if you want to see what is the mean error, okay, so we can actually calculate the difference and calculate the mean. So the mean difference is negative 3.12 times 10 to the negative 19th power. So there's a non-zero difference, but it's very small. Okay. Okay, so I hope you like this video. Again, naivebayes is naive but very easy to use. So you may want to apply this classifier first, and then if you have a more sophisticated, more accurate, and more computing intensive algorithm, you may be able to combine the two to do some kind of double sampling, and so that you can actually like calibrate the naivebayes classification using the more accurate classifier, and at the same time saving computing times. Okay. All right. I hope you like this video, and please support our channel by subscribing to our channel, like our video, and also click on the notification button. That will help us out for our channel to meet favorable rating from the YouTube algorithm. Okay, the algorithm. Okay, thank you so much. Bye.